Hello there everyone, and welcome to the second tutorial on Fusion 360. In this tutorial, you will learn how to create basic sketches, use certain patterns such as the circular pattern, a rectangular pattern, and features such as mirroring. Next to that, we will also see how you can import points from Excel. In this case, we will be using it in order to create an airfoil. Okay, so in order to get started, first of course, open your project or just open Fusion 360, you will get a basic project opened. And in order to create a sketch, you can either click the Create a Sketch button or just press L. Most of the time I will use L because it kind of reminds me from the function of line, which you can use to just create basic lines. As you can see, now the origin appears. Here you can choose which plane you want to sketch on. So you can choose the ZX plane, the XY plane, or the ZY plane. In this case, let's go for the X and Y plane. Okay, so now we're in sketch mode. As you can see now, here we have our sketch palette. On the side, we have our ribbon. So for our first example, let's create a basic rectangle. There are a few ways you can do it. So you can go from corner to corner, as you can see here. This is creating a rectangle from corner to corner. But you can also choose to do it from center. Or create it by defining 3 points. For this example, I'm going to use one that is created by its center. Okay. As you can see, here we have some signs that these sides are parallel to each other, and these are called constraints. As you can see here, there are a couple of constraints, such as the horizontal or vertical constraint, which will make a line either parallel to the horizontal or parallel to the vertical, coincide. So you can use this if you want to make sure that a certain point coincides with another point. This will be shown later. And a tangent function, an equal constraint, parallel constraint, perpendicular, fix and unfix. Like in most cases, fix and unfix is just if you don't really have a specific constraint for it, but you just want to pin it down. Like, I think this is the best description for it, just wanting to pin something down. In most cases, I'm not really a fan of it. Like, if you can, please try using some other constraints, but in some rare cases it could be that you will be using it. Then here you have midpoint, if you want to make sure that something snaps to the midpoint of certain objects, such as a line or the side of a rectangle. Then concentric, if you want circles to concentric with each other. Making something collinear, having symmetry, or making sure that for instance, if you have a line and you have a certain curvature and you want to make sure that they attach smoothly to each other, you can use this constraint. But in this case, let's just use the coincident constraint. So I want to make sure that my center point of the rectangle coincides with the origin of my X and Y axis. So to do this, just click coincident and click center point of the rectangle and the origin. And as you can see, it just moves to the origin. But as you might have noticed, it's still blue. So in Fusion 360, once something is fully constrained, all the lines turn black. So why is this? Well, it's because we haven't defined the dimensions yet. So in order to define the sides or give the sides a certain dimension, you can either press the dimension button or just press D. In this case, I'm going to press D. Let's say make this 75 by 50. And as you can see now, it turns completely black. In this case, it's fully constrained. But let's look at another constraint, such as the equal. So what if I don't want to have a rectangle, but I want to have a square? Well then, let's just keep one dimension, such as 75, delete the other dimension. Now let's press the equal button, select this side, and select the other side. And now we have a square from 75 by 75. Okay, let's move on. For creating a circle, you can also just press the circle or use the shortcut C. Now we have two circles. Let's make sure that one of them is in our origin. And if we want to make sure that the other circle is concentric with the circle that's now in the origin, you could just do it by selecting the midpoint or the center point from the circle and selecting the origin, or you can use a constraint named concentric. And you can just select circle in the origin, circle that you want it to be concentric with, and now it will be also moved to the origin. But you might be thinking like, okay, you've done it, but why is it still blue? Well, that's because we still haven't added the dimensions. So let's just say the outer one is 70 and the inner one is 50. Once we've done that, it's fully constrained. And just to demonstrate it, like, because it's fully constrained, I can't move it. So if I take the center point from the circles, I can't move it anywhere. But if I remove one dimension, and if I now take the perimeter of the circle, I can increase its radius or decrease it. So that's why it's so important to have constraints, because you don't want to accidentally change the dimensions of a certain part. That's why it's so important, because for instance, if you're moving your object, it could be that this happens. So yeah, make sure that your sketches are always constrained. Okay, so now we have a circle. Next one is like a more complex shape. So let's just make a quick doodle, just like this. Okay. Let's now put some dimensions on. As you can see, like if you draw a line to the origin, it will automatically be constrained to that point. But if you would just do it here, like in an open space, it's not constrained. Okay, so now let's just put some basic dimensions on it. 60, 30, 10. Let's take 15 for this one, and 25 for this. Okay, so now you have created this shape, but what if this is not the shape that you're looking for? Like, what if you want it to be mirrored? So if you want to mirror it, there are two ways you can do it. You can just draw it manually, like this. Let's see one. So this is one of the methods that you could use, and then just add all your dimensions. But it's quite time consuming, especially if you have large complex parts with like lots of holes. It's quite time consuming. So there's another way that we can achieve the same thing, and it's just by using the mirror tool. So as you can see here, we have a mirror tool, and when you click on it, it will open a new tab where you can select your objects. So first of all, select all the objects that you want to be mirrored. Then select your mirror line and just press OK. As you can see, it's mirrored and fully constrained. Note, however, that If you delete one of the dimensions, you can see that both the original and the mirrored image from it will be not fully constrained. So also make sure that your sketches are constrained. I think I can't stress it enough. Constraining is really important. Okay. I think we've seen like enough of the basics. Like I suggest you experiment a bit with different shapes and different tools that you can use, but these are like some basics, like especially to stress how important it is to be using constraints. But now I would like to move on to something else, namely how can you import points into Fusion 360. Namely, if you have some points in Excel, some coordinates, how can you import them? Okay, so in order to do that, first let's search for some coordinates. And in this case, let's go for an airfoil. I mean, most of you are studying aerospace, so why not go for an airfoil? Okay, so now you can see we're at Octoprint. This is the airfoil generator, so you have a 4 series and a 5 series generator. So in this case, let's just use the standard one, camber of 2%. Okay, thickness. Let's choose a bit more points. Like most of the time, I'll use the maximum of points, and make sure to close the trailing edge. Okay, now press plot. Then here you can see the DAT file. If you want to import it into Excel, first open Notepad. Copy your points. Paste them into Notepad. And just make sure that they're well aligned. And then just save it. Save as, so in this case I'm just going to save it on my desktop. NACA 2412. Okay, save. Now let's import it into Excel. Okay, so what you want to do is, once you have copied your coordinates, you want to open a new Excel file. Open, browse, and now let's search for text file. Select the text file, and now you will get this this text box. Click next. Make sure that your columns and rows are like correct, like no abnormalities occur in it. And let's now split it using the space. So as you can see, now we have 2 columns with our coordinates. Okay, press next and finish. Now we have all your points inserted into Excel. But what you want to do is you want to multiply it by a certain chord, because we don't have wings that are just one long. Yeah, but you could make it, but if you want to make custom like airfoils or wings, you want to have a certain chord. For instance, a chord from like 450 millimeters or a chord from like 1 meter, you name it. You want to be able to do that. So let's go to an example. No, it's not this one. Yes. So what you will do is you will define your chord in centimeters. This is very important because Fusion 360 in its core uses centimeters as its basic measurement unit. So like in lots of cases you will define everything in millimeters. That's what you did in your settings. Once you start Fusion 360, you will say, look, I want to use millimeters as my standard unit of measurement. But in the background, Fusion 360 uses centimeters. That is why in some scripts, also the script that we will be using, the unit that will be used is centimeters, and you cannot change that. Of course, there is a possibility to change the script using something like your Visual Code or some other editing software for codes or scripts. You can do that, it's perfectly possible, and make some kind of conversion factors so that if you fill it into millimeters, that will first convert it into centimeters so that Fusion 360 can use it. But in this case, let's just use it straight ahead in centimeters. So for this example, it's a chord of 300 centimeters or 3 meters. And yeah, you will just use a formula. So as you can see here, you have a formula. So multiply both your x and your y value times the chord that you want. Then copy the formula until you have converted all the coordinates. And what we will do then is just copy these coordinates and paste them into a new file. So open a new Excel file and then paste your coordinates as numbers. So pasting them, so let's just give the example like this here, and you will paste them as a number or a value. This is what you will have to do. But note that if you don't define your z coordinates, it will give an error. So always make a column with z, and in case it's just a 2D sketch that you want to create, just fill it with zeros. Okay. Once that's done, you'll go to File, Save As. As you can see here, you want to select the CSV file format. So the command limited, you'll have to choose this one, save it somewhere. In my case, this is just on my desktop. Like you can see it wants to override it. So let's not do this. Let's not do that this time. But we have our coordinates. So what we want to do next is import these coordinates into Fusion 360. So here we are still in our sketch palette. And in order to import it, we will be using a script, as I mentioned before. So in order to access the scripts that are in Fusion 360, let's go to Tools, Add-ins, Scripts and Add-ins, and now search for the script import spline CSV. Click on it, and then press the Run button. It will ask you to search your file, and in my case it's already selected. And if you press Open now, it will import your airfoil. As you can see, it's fully closed at the end. That's why it's so important to close the trailing edge. Otherwise, you will have like an opening here, and it will be difficult to extrude it. Like you can fix it just by manually placing a line, but it's easier if you don't have to do that. As you can see, like we have a point here at the center. Let's make sure to constrain. And now let's just hit Finish Sketch. And if you would now press the E for extrude, you can extrude your wing. But let's not do this for now. Let's just keep editing our sketch. Let's make some holes in our wing for, well, let's just say mounting the rib to some other components. For instance, the main spar, or like a torsion tube, you call it. So let's make an opening of 200 millimeters. Let's say at a distance of about 300, about 1000. Yeah. Let's place that one here. Add an elevation. Also make sure that you always have the right point. Okay, so once you have the height, let's just say 50 from the quarter line, and let's now look to make a rectangular pattern. Let's say I want to have 3 of these. So just select it using the rectangular pattern. It has a quantity of 3 selected, and now you can just move it until you have the specified distance between the 2 center points. In this case 575. Let's say we want about 700. This seems okay. I can do this direction, but let's say if you have a bigger plate, you can also do it in this direction. So you can change the quantity and the distance between the center point or the reference point that you're using, and that will change how the pattern looks, but you don't have to do it in both directions. If you just want a certain part or sketch to have a certain pattern across a line, you can just use the rectangular pattern function and just use it in one single dimension. For instance, in this case it's across the x-axis. Okay, let's press OK, and this will create your 3 cutouts. Now to finish it off, let's just look at the circular pattern. Let's place a circle of 20. A distance of 120 from the center. Let's say from our midpoint we have the same distance. We also have 1000. Okay, that will make it fully constrained. Now create, go to circular pattern, select the objects that you want to use, and then select the center point. In this case you could just select the center point of the circle or just the perimeter of the circle. And now you'll be able to fill in the quantity that you want. So let's say we want about 10 holes. Let's say these are mounting holes, for instance. Press OK, and now it has created that. Once you're finished and you're satisfied with how your airfoil looks, you can just finish your sketch and edit it. For instance, extrude it. In this case, let's just extrude it to like 10, and now you have your wing rib ready for use. As you can see here, you have the origin, where it's placed. Okay, so that was it for this tutorial. I hope you enjoyed it, and if you have questions, feel free to contact me. And of course, also make sure to check out the Autodesk Fusion 360 online video tutorials. They're really useful, contain lots of tips. So I hope you enjoyed, and